Hello everybody. I'm going to talk about exceptional call 6, which is everything that is related to exceptions and error reporting. This is important for us because everybody who starts programming call 6 is new to the language, including ourselves. So we make a lot of errors, and so we want to get good error messages. So this is my favorite not good error message. It's in Linux. We have the root command with which you can add network roots, and it just gives some weird word or abbreviation and no such process. And I always find this is a real what the fuck. Why? Well, first there's this obscure acronym for which I haven't found any explanation even after searching for it for a while. It complains no such process, but I didn't even want to kill a process or so. I just wanted to add a root. I don't see the connection at all. There's no explanation what actually went wrong, and no explanation why something went wrong, and no explanation which of these parameters I need to tweak. And what's even worse, there are several conditions that can lead to that error. So if you Google for that error message, you can find, either there's no route to the gateway, or the route already exists, or, well, some other conditions depending on the route phase and so on. So here's the second example. I think you're more familiar with this one. I tried to compile some POP5 code, and you probably already spotted the error. There's a closing parent that's missing. So, and it says syntax error at -e, that's the file, that's good. Line 1 near parent bracket, Perl, sorry. So, and it says execution of -e aborted due to compilation errors. That's better. It tells you which level the error is on, so it tells you it's a compile time error, it tells you the error is fatal, and it tells you where it is. But it's not yet awesome, because it doesn't tell you what the problem actually is, just that it's a syntax error, but there are so many ways to screw up the syntax. It could just tell you, you opened a round parent, but you didn't close it, for example, or you closed it with the wrong parent, or something like that. So we decided we can do better. Here's an example error. Okay, it's maybe a bit contrived, but it actually works quite well in practice. So I declare a subroutine, and then I try to call it, and I actually made a typo, and it says, sorry, error while compiling -e. So again, we know it's compile time, and we know it's -e, and it says undeclared routine, elegant used at line 1. Did you mean elephant? So there are a few useful features in there. The first is not actually related to error reporting as such, but rather to compilation. It tells you at compile time that this routine was missing. So you catch that error even if the code path in your current test doesn't go over it. There's a suggestion for alternatives, which actually works quite well, and it gives you, I think, up to 2 or 3 suggestions, and only if they're reasonably close. And what you don't quite see from the message is it does batching. It can report several errors and several occurrences of the same subroutine inside a single error message. So you can, if you have misspelled the same routine twice, for example, because you are not used to the keyboard or whatever, it will tell you both occurrences in the same error message. So now I want to jump to the user view of dealing with errors. The first thing is you can throw exception with the die routine or keyword or whatever you'd like to call it. Here I have a subroutine that might die, and okay, bool, the type bool is for boolean, it's an enum type, and .pick randomly returns one of the elements that returns true or false with equal probability. So in half of the cases that we call that routine, it will throw an exception. And we can then catch the potential exception with try. There's a difference from Perl 5. Perl 5 uses eval for that. And you can see second difference. If you look very close, you don't have to write the semicolon after the closing brace, which is an error I always make, especially when it's on a line of its own with closing brace. I always forget that in Perl 5. I'm very glad we don't need it here anymore. So if there is an exception, it's stored in $bang, not $@ like in Perl 5. Perl 5 distinguishes I/O errors, which are in $bang, or let's say operating system errors, and eval errors, which are in $@, and Perl 6 unifies those into a single variable. So if there is an exception caught, we'll say good luck, and if not, we'll say bad luck. So there's another simplification. You don't actually need the curly braces, because try is what we call a statement prefix. So you can, if you only have a single statement or expression afterwards, you can omit the curly braces. And in Perl 5, there are two forms of eval, the string eval and the block eval, and they do totally different things, but not quite, because the string eval also catches exceptions which normally only the block eval does, but it doesn't catch all exceptions, because if the string you pass to the string eval in Perl 5 actually has a compilation error, it will still throw an exception. So in Perl 5, to be sure, you'd have to write eval block, eval string, to be sure that it never dies. And in Perl 6 we decided we completely decoupled those two, so try only ever catches exceptions, and eval only ever evaluates code, and if there's an exception inside, it is just thrown to the outside, and you can separately catch that with a try. So you might wonder what exactly is in $bang. Let's find out. We use try as a statement modifier, and then die simply with a string, as you would normally do in Perl 5. And then we have the handy .perl method, which is basically what data dumper in Perl 5 does, which is it gives you Perl code which would reproduce this object. And you can see that it's an object of type X ad hoc, and the payload is the string that we provided to die. Now there's the next line calls the MRO method, resolution order method, and meta object. So this gives you the list of the class itself and its parents, and you can see that it inherits from exception, and exception inherits from any, and any's are basically normal base type, and then there we have mu over that, which you usually don't care about. So there's this convention that except for the base class, which is exception, all the exception classes start with an X : : and then if you're in an application, you would put your application name and then : and then the name of the actual exception. So the contents of $bang is always something of type exception or subtype thereof, and if the argument to die that we passed to die isn't of that type, it is wrapped in X ad hoc. And the reason is that this way we can propagate useful meta information, which is mostly the backtrace, but we can also access the message, and we can throw or rethrow exceptions and so on. So that's why it's useful to actually always have an exception object if you call an exception, and not just a string or whatever you pass to die. So there are lots of built-in exception types. I think we're now at about 30 or 40, and I have two examples for you. The first is the typical I/O error. We tried to change the file permissions of directory /, and of course I'm not running that as root, so it will fail. And $bang.message gives just the error message as it would be printed, but without any backtrace. And here it says failed to let the mode of / to 00777, and what follows is the what I call here the operating system error, but actually it's the error that the underlying virtual machine, in this case Perl, gives, and Perl says change mode failed, operation not permitted. And as you can see in the second line, I also print the Perl representation of that object, and there you can see that all of the data from this exception isn't just put into a string, but it's actually easy to extract that data. So you can, for example, just access the .path method of the exception object, and you will get the path that was passed to the change mode function. Here's another example. There's this function for converting strings to a number in a certain base, and it says :16, so the string afterwards is interpreted as a base 16 number, but if you pass OH to that, it will complain. And here it says cannot convert string to number, base 16 number must begin with a valid digit or dot. And it also puts this eject symbol at the point where it couldn't parse the string anymore. And again, if you look at what's actually in the object, you can see that the string that was passed on to this function internally is directly in this object, and in this case the position where the error occurred, so, and finally the reason, and then the stringification is just done by this method called message, and it put like this eject symbol in there and so on. And of course you can build your own exception types, and you should, if you produce any errors, and they're by no means special. They're not differently than the error types that we have in Perl 6 itself. So our built-in exception types are built exactly the same way.
Shouldn't that be is exception there?
Oh yes, thank you. So, right, I forgot the most important part. They should, of course, inherit from class exception. So imagine here before the first opening brace, imagine an is exception. So it has two attributes, age and minimum age, and a message that says with 8 years you're too young. And how do you use that? Well, in Germany, the minimal age for many discos is 18, so if the age is smaller than 18, it will first create this exception object, and then these are two just two different syntaxes for passing named arguments. If the key happens to be the same as the variable name, you can just put a colon in front and you don't have to repeat the h from the variable name. And so now you have the exception object and you can pass it to die. Or if you don't want that, you can just call the method .throw on the exception object and it will throw the exception for you.
In the previous example, the previous slide, how would you like to support translations in the error messages?
That's actually still an open question. I'll get to that later. So we call the function we just defined, we prompt for the age, and then enter disco with that age. And now we've seen try. Try will catch all exceptions. But sometimes you only want to catch some exceptions. So catch is the low level, but also the most general mechanism for catching exceptions. First, you can see it's a block in the same scope as the code that it catches the exception from. This is different to Java and Python, where it's often where the code that is inside, where the exception is called from, is an inner scope. We have a different design because we want all the variables to be available in the catch block, so that even if the exception object doesn't have the information we want, we can still easily access all the lexical variables. So this catch block receives as a topic, as the $_ variable, the exception object, and the contents should be smart matching clauses. So we have this when, and the body inside when is just executed if the exception matches the type X disco to young. But you don't just have to, you cannot just use types there, you can do any smart matching you want. So you could, for example, put a code object there that returns true or false depending on whether you want to catch that exception here or not. And then you can do the error handling, and if there's no default block and none of these clauses match, then the exceptions will be transparently rethrown.
So what's the scope of that catch in terms of the block of code it's catching exceptions from?
It catches exceptions from all the code you see above it. So it's from the
Everything from the code last opening brace?
It's everything from the block it's in. So if there's code below the catch, it would still be responsible for that.
You could put the catch block at the top or the bottom.
Oh, right,
yeah.
okay.
Okay, so when would you want to do that? Catch only some exceptions, pass other ons. One is, for example, if you do transport of a network, you might just want to distinguish temporary errors and permanent errors, and you might want to retry on temporary errors a few times. And another good use case is you might want to distinguish user errors from internal errors. So if there's some kind of text field and the user is expected to enter a number and it doesn't parse as a number, you don't want to die with a complete stack trace, you just want to say, oh, I couldn't do anything useful with that. Whereas, for example, if there was an internal error, you might want to save the complete backtrace to a log file or ask the user to file a bug report or do whatever. Or if you're doing remote procedure calls, you might want to distinguish transport errors from the errors that are actually thrown by the remote party. So for example, authentication errors might be handled differently than if the connection actually worked, but something went wrong on the other side. Okay, I mentioned backtraces a few times. In class exception, there's simply a method called backtrace, and it gives you, what a surprise, a backtrace object, and the backtrace object is a list of backtrace frame object, and it also has some methods for printing the backtrace in a nice way. So each frame has the file and the line, and in future maybe also the column. We don't have that implemented yet. And it has actually the code object of that backtrace frame. And the default stringification of such a backtrace does a lot of filtering. I want to show you what it does and how it does that filtering. So I have here an example. I have a subroutine, and in that subroutine there is a loop, and inside the loop there is a die statement, and then we call the function and actually catch any exceptions, and then print the backtrace, and then there's the .full method, and we print that too. So the first backtrace is what you would basically expect. You can see it's inside subroutine F, and in that subroutine the die statement was at line 3, and then there's an unnamed outer block, which is the main block, and there line 6 was what called function F. This is basically the same as you would get from Part 5's card confess. And full looks a bit differently. It's actually so large that it doesn't fit on the screen here. And it contains lots of internal stuff. Why does it do that? Well, we use Perl 6 to implement Perl 6. So much of our runtime is actually written in Perl 5 and in Perl 6. So you can see that subDie actually calls the method throw, and you can see that for example, there's this method readFi and the method gimme and eager, and you wonder, well, you already see they're coming from a file name with core in the name. Core is what we call the runtime that we've written in Perl 6. So what actually happens is that this for loop is the same as .map on a list, and that map of a list is a lazy list, and so the compiler calls the method eager for you so that it actually executes the loop, and that eager says give me a few elements or give me all elements, and then that does some internal magic, which if that interests you, you should invite Patrick Michaud for a talk, and he will tell you what it does. I haven't quite understood it yet. And at the very bottom, you would also see that the entry point into the program, like there's always at line 1 a call into that basically just calls the main program. So there's lots of information there that doesn't actually interest you. And so we put a lot of effort into filtering backtraces to the parts that interest you. And I want to tell you a few things that we do. Oh, that's the stuff that I just told. There are lots of implementation details from the lazy list, for example. Okay, to the filtering. First, we mark some routines statically as being hidden from the backtrace. There are some routines that should never show up in any stack trace because they're purely internal and nobody's interested in them. And then usually from the setting, from the core that I just mentioned, those routines we also ignore because we just want to, well, if they actually die, it's because they some code that we gave to them as a callback died, usually, so we're not interested in that. And then we do a fairly interesting thing, that is, there are actually 2 chains in which routines can be linked. One is what we call the static chain, that's just how those routines are nested in the program code that you look at. And the second is the dynamic call chain, that is the way they actually interact and call each other. And if a routine appears both in the static and in the dynamic chain, you will almost certainly want to know about that, because it's a routine that you look at while you're debugging this program, and it is interesting for you because control flowed through it. Okay, that is the standard filtering, and I want to demonstrate how to do some other filtering. As a use case, those backtraces are great for us developers because they tell us how we got to the point of the arrow, but the user isn't interested in that level of detail, and the user doesn't care about the internal structure of our program. But on the other hand, sometimes we might want to give our users some context where this error occurred. For example, the user wants to quit a program and it says, oh, I couldn't write to a file. And the user says, why? I didn't ask you to write to a file, I just wanted you to quit. So we can give a bit of context and say, well, we actually write a file because we were saving your configuration to disk or something like that. So I've decided to implement such a thing as a filter of backtraces. First we need some preparations. First we declare a trait, and later we use that trait to actually mark some routines as being interesting for these kinds of backtraces. So we are declaring a multisub. A multisub is just a subroutine of which several candidates with different signatures can exist. And here it's trait mod, it's a trait modifier, and the trait will be applied with is. So that's what the is in smaller greater signs is there, and it will be applied to a routine. The smiley D just means it needs to be defined. It can't be the routine type object, it must be an actual routine object. And there's the mandatory name parameter user facing, and that will be the name of our trait. And inside this trait we mix a role into this routine. So that's what the line with R does describe and so on does. And this role is parameterized by the text that we will give the trait, and it just adds a single method called descriptor, short for describe, and it returns the description. So as an example, we say, well, if this program exists, we want to save the state, and one of the things we do for saving the state is saving the configuration file and probably lots of other things which I have omitted here. And the save config subroutine, we give this trait user facing, and the user facing description is saving config. How surprising! And in there we do an operation which fails just for the sake of demonstration. And then we call this save state routine, and save state will call save config, and we catch exceptions with prime. And then if there is an error, first we print the error message, and then we go through the list of backtrace frames. And now comes the clever part. I already told you that each backtrace frame actually stores the actual code object, not just a name or anything, but the actual code object. So we can see, does this code have a method descriptor? And if yes, we know that this is the user-facing description of the subroutine. And if so, we say yes, and this error happened while this step of the program was executing. So this is what it will look like. Error unable to open file handle from pass, no such file directory, while saving config. And if there were more routines in the dynamic trace with this trait, then more of these while lines would have shown up.
Question.
Yes?
Any particular reason on the last slide that you chose duck typing instead of just matching against the role that you had? Named the role and everything. Like it was local because of the mine, so you can't get at it from that.
Okay, I'll repeat the question. The question is, why did I use this can method instead of a type check?
Yes.
Because the motivation is I already mixed in a role, so I could just do type check against the role. And the reason is, well, it was just simpler to do that way, and if you want a different mechanism to mark some subroutines, you can do that too. You don't have to actually mix in that particular role.
Okay. Thanks.
So
You could also do the duck typing simpler just by doing conditional notable.
yes, I could, but yeah. So there's more than one way to do it, as you can see. Okay, so what I've learned from my work on the exception stuff, so I was the guy who actually implemented much of these type exceptions and the underlying class and role model. The most important stuff I learned is that it's good to pack all the potentially interesting information unfiltered into the exception object, and then only when you actually print it, you reduce it to the information that you want to present at the moment. And this applies both to the actual exception object and to the backtraces. So there's still the full backtrace available, but it usually only prints the filtered one, because, and the reason this is important is that sometimes people want to see a different view on the error than you will, and you're usually not good enough at anticipating that to make this decision for them. So instead you just put all the information unfiltered into the exception object, and it also has the advantage that the caller can just call some, the catcher can just call some methods to extract the data in a useful way without parsing any string. And for example, PAL5's carp crow, which throws exceptions from the perspective of a caller, could just be implemented as a filter on the backtrace. So there's no need to actually modify the code that that throws the exception. You can do that at the site where you catch the exception. And I want to say that in the PAL6 community, the error reporting is very important for us. We take error reporting seriously. Every time the compiler or the runtime or any module gives an error which doesn't really explain what's going on, we say, oh, this is less than awesome. And we even have an acronym for that because we use it so often, and it's no question that this is a bug if the error is good enough. And there's also quite often people want to suggest some new syntactical feature for PAL6, and usually they want to allow 2 terms in a row for that, and it would screw up about half of our syntax error messages, and we simply don't do that because it's more important for us to give the user proper feedback than to actually have even more syntax than we have now.
We got plenty.
We got plenty syntax, yes. So there are still some missing bits. While we strive to be awesome, we aren't always awesome yet. And one is exception, translation of exceptions. We have no proper plan for that. I have a few prototypes that work. You can either monkey patch in different methods, or you can And another idea is to, instead of using this message method, we basically do a message format method instead, and then the one who catches the exception can use a translation table on that. But we have nobody really working hard on that problem, so there's not much progress to be expected soon. We don't quite know yet how we deal with user-defined warning objects, because usually, okay, there are two. The big difference between an exception and a warning is that the warning is always resumable. So a warning is a resumable exception, so that could either be a bit of information in the exception object, or it could be a bit of information in the channel that throws those exceptions. So we don't quite know yet how we model that in the user-facing way. Then there is the simple error, the simple problem that not all of our errors have those fancy types. Some still just use a die and then a string, and we need to port those to proper error types. And then there's another open question: if we want to integrate logging and error reporting somehow, but I kind of guess that's a job for a module. Our system is flexible enough that this should be easily possible. And one thing that we're missing is we can't really export those catch blocks from a module. You can just export the logic that's inside a catch block. So, for example, if I wanted to write those user-facing backtraces as a module, I would still have the user of that module would still have to call try himself, and that's not nice. So we're kind of working on ways to fix that. So we are nearly at the end. As a summary, we have cleaned up these exception constructs with eval and try, and we add catch, and we encourage the user to use his or her own exception types, and we try to follow with a good example by using those in the compiler. And as a bonus, it makes testing much easier, by the way. We try to carry as much as interesting information unfiltered in the exception object and filter display time, and the system is extensible enough that many of the remaining open bits can probably be solved in modules and not in the core language. Thank you very much. Do we have time for one or two questions? Okay, 2 minutes. Yes, please.
In Perl 5, some programs use exceptions, die, as sort of way to control flow of the program. For example, abort, and at top level you catch this exception and you continue execution. And when your exceptions contain backtraces, and usually in P5 you have to pre-build backtrace, collect all stacks, and it makes abort much slower. We had to monkey patch such system to skip all backtraces. How to do it in Perl? Can you we'll need backtrace, let's say as minimum, and
so the question
later.
The question was how can we optimize our exceptions not to record this backtrace information so that we can make exceptions using control flow more efficient? And the answer is that we have a separate channel for control flow exceptions, and we haven't really exposed that to the user either, but this is something that that will be coming, and we probably won't use the full exception objects for those. So there will be some other
exceptions.
Sorry?
Lightweight exceptions.
Yeah, we have
We use those already for return.
Yeah, for example, returning from a routine that can go through several blocks, and we do that with control exceptions. and we don't record backtraces for control exceptions.
Art is the backtrace, please.
It has to obtain its information somewhere. I don't quite know yet at which point it is
I mean,
obtained.
if it hasn't been rolled the stack, you could just keep that.
Yeah, I don't know. Do I have time for another question? Any other question? Yes.
What's the scoping of a $bang variable now? Because in Perl 5 I've always had a problem getting polluted by
$bang is lexical.
it. Is like
It's that simple. Okay. Thank you again, and goodbye.